Hi everyone. It's an honor to be here to present our papers. The topic is explaining recommendation in interactive hybrid social recommender. This is work from me and my advisor Peter Berlovsky right here, the chair in these sections. So the idea for this paper is that is hybrid social recommender system usually is kind of rarely adopted in many real-world applications. The idea is very simple. We try to solve the issue for information overload. So we use a different kind of signal, different kind of data, and we try to eliciting the user preference, and we provide a set of recommendations so people can reduce the time when they make decisions. So usually this kind of system leverage multiple information sources, usually using ratings, bookmarks, publication, social network. And the goal typically is try to come up with optimal static fusions. So we give you a list of recommendations and we try to give it most accurate to have highest accuracies. This is the transformation goal. But we find in the previous couple research projects, we find it's pretty hard to fit one static recommendation list to the changing information need, because you can imagine the user may need a recommendation for different reasons. So if you try to provide one fit for all recommendation list, somehow it's pretty challenging. So in our previous paper, it's actually this published in IUI 2018, we provide one controllable interface to the user can tune different weightings by the given 5 different features. So for example, if you want to find somebody kind of closer to your research group, you can tune the red color bar, increase or decrease them, or you can see if somebody is kind of more relevant to your topic. It's based on that. We call it user control hybrid fusions. This interface we call it relevance tuner. So if we consider the process of recommendations, we have data, we have a process of reasoning process, then when fusion, we have a list of recommendations. So based on the relevance tuner, the people can do the fusion pretty well. It's controllable fusion, right? They can tune by different weightings. But for this interface, one thing is still missing because the data and the reasoning process is still not clear. It's not transparent to the user yet. So for this paper, we try to solve these questions. How we can provide transparency to the data and the reasoning process using this interface. It's an interactive, controllable interface. So the idea is that we try to provide one we call explanation icons. So the only thing we change is that we provide one like a icon next to each of the recommendations. So if you can tune based on different sliders, and once you feel satisfied with the rating, you want to know more, you can click the icon to get more explanations. Once you click, we provide new windows. So based on each of the cell, you can click, it's clickable, and you can get Y, the relevance equal to a certain number. Let's say Y relevance equals 10, and you can have a one visualization tell you what kind of data we do, and you can use that to get some idea what's going on behind the scene. So I will introduce one by each. The idea for, we have 5 different recommendation features we call similarities. The first one is publications. So the first interface we provide is that we try to tell you why the relevance score equal to 10. It's a very simple formula. Tell you, okay, publications relevance equal to 10 is because we use your publication similarity and times the tuner weightings. Because I didn't change the weighting, so it's 5 over 5 is equal to 1. But the next thing is that it didn't tell me how do you come with the similarity score equal to 10. So we provide one additional layer for visualizations, tell you why the publication similarity equal to 10. The idea for that, for explaining the text similarity, we call Venn diagram. So for these features, it's calculated by the cosine similarity based on your publications. So for this interface, the user can say, okay, my term is working on visual study and features. The other one is the other scholar working on profile network. And we have the system, user, business, the word is common word in the middle. So the more words in the middle means like we have more relevance and you know exactly what kind of term we use to calculate that, okay? And the second one is we call topic similarities based on the topic modeling. So we calculate this similarity based on topic modeling with LDA and for research interest. So for these ideas, we call a radar chart. So we try to show in the left-hand side, we show the top 5 research interests in the radar chart. So you can see my research interest is topic 14, 20, topic 8, 6, 7, and 23. And the other one is in the yellow, is in the red color one is 14, 20, and 23. And we have overlap in topic 14s. It's overlap 47%. And you can see the topic word right here. Topic 14 is contributed by user recommendation and recommender system. So it means like this scholar working on 2 different areas, but we have one topic overlap in research. And you can use the readout chart and the table right here to understand how did you come up with the high topic similarities. And next one is what we call co-authorship similarities based on the user's co-authorship network. And the idea is we try to leverage the degree of network distance based on the shared co-authorship network, like in the conference, like here. So the idea for explaining this is using a graph. So we can see if you want to connect from Chu to Neff, you can have a distance, right? So you can connect from Chu to Peter, Helen, Hansen to Neff, or Chu to Peter to Jem. You have 2 different paths to connect from 2 scholars. And we try to get the average degree to how you can connect for 2 scholars based on your co-authorship network. So we have 2 more because of time limit. I skipped the last 2. If you are interested, you can take a look for the papers. So based on this, given these explanations, the idea is that how we want to see if we provide explanation icons, how you change the user perceptions. So when we try to do an evaluation by the conference navigator system, this is a social support system proposed by our lab. And we send out email to recruiting people, 345 email sent to the attendees for HyperText 2018, UMAP EasyTail 2018. And we got a response for 33 scholars. 12 of them are female, and they participate and eventually complete the study. So it's totally voluntary, so we didn't pay anything. It's online study. And the design is online study. So the user is kind of free to explore anything. They just free to use the system, whatever they want to do. And within subject design, when compare between relevance tuner, the interface we did in the previous paper, and this one, relevance tuner plus the explanation. So only difference we can control only for the icons. Baseline and the target interface. The only difference is the icon right here. So we ask the user to do 3 different information seeking tasks. It's repeating same 3 setup, 3 tasks, repeating each interface. So for example, I give you one example here. I ask you, can you find 4 committee members for your dissertation defense? Try to be real. So the candidate should be a senior scholars who have expertise closer to your research field. So should be senior, should be close to your research field. When you try to make it real, you need to use the interface to find out who is the best one, and you need to follow using the follow button right there. And after that, we send out a questionnaire to the user to see how do you perceive for both of the interface. And the result, we find out the first thing is that we find 90% of the participants extensively use the sliders in the top. So they use a slider to complete the 3 assigned tasks, 90%, pretty good. How about the explanation icon? Surprisingly, only 50% they actually click on explanation. Let me explain this. This is an online study, so they are free to choose they want to use or not use, right? We find out only 50% of them they actually click on the explanation icon. And in overall, if we provide explanations, the users spend more time to interact with the interface. They spend more time to finish the task when assigned to them. So the next one is that how's the user feedback? We find out, we actually have more, but we find out significant effect in 3 of them, 3 of aspects. So if we provide explanations, yes, the user feel more transparent, so they kind of feel explainability is increased. However, we find out the negative impact. Let's say if we try to provide explanation icon, the easy to use feedback actually is kind of decreased, and also the perceived control is decreased as well. So we find a significant effect on the 2 of them. So when we try to explain why this happened, so when we try to run SEM model, the structural equation model by that, we find out it's because if we compare the baseline and the treatment interface, we find out if users tend to click more, when they click more, they spend more time, and they will perceive less control based on that. You can find out here, let's click more, they spend more time, and kind of leading to less control. The second one is that when provide explanations, not directly contribute to perceived transparency. So they don't directly contribute to that, but for the user who actually can perceive transparency, they have a higher certifications. This is how we find based on the data we collect from the online studies. So give a quick conclusions that in this paper, we present new interface. It's explainable recommendation in the interactive social recombinator. So we have Relevance Tuner, we have Relevance Tuner Plus, combine two things. And the key message I want to deliver here is that we find interesting perceptions that say it's a trade-off between controllability and explainabilities. Let's say if we provide explanation icon, it seems that people perceive less control. And why? We don't have we try to give explanation here, but it's still ongoing study. We find the user kind of slowly improve the mental model while they interact with the system. And if you provide a very detailed, like the approach we provide, the interface we provide is very detailed, full explanation, maybe a little bit excessive to the users. So it leads to a negative impact on user confidence because maybe it's too much, so they don't actually need that kind of explanation while search the committee members, for example. And also it leads into less enjoyment because it seems like they need to process more information while completing that. Okay, so that will be the information that we want to deliver for these papers. And that's it. Thank you. And do a quick advertisement in the market. If you have any position opportunity, refer to me. Thank you so much. Thanks.